Hello, welcome to Madam YY channel. Today we are going to look at the chemical reactions of alkane. So basically alkanes will have two types of reaction, which is combustion and halogenation. So today we are going to discuss further on halogenation. So halogenation is a reaction between alkane and halogen. So normally the halogen used will be chlorine and bromine because iodine is too slow to show reaction and fluorine is too violent. So the product from halogenation, you will get a mixture of alkyl halide and hydrogen halide. Halogenation will happen in the presence of light or heat. So light and heat act as a catalyst to produce energy for the homolytic cleavage. Halogenation is also known as free radical substitution. Okay, so let's write the products and show the mechanism of the halogenation of alkane. So in the sample, we are having 2,2-dimethyl propane. So when it reacts with chlorine in the presence of light, what is the product we will get? So based on the compound, the chlorine atom will substitute one of the hydrogen atoms. So the hydrogen atom in this compound here are equivalent. All the hydrogen atoms are primary hydrogen. So means that the chlorine can substitute at any of the hydrogen atom and the product get will be similar. So here we will get 1-chloro-2,2-dimethyl propane and HCl. So next we are going to learn how to show the mechanism. So there are three main steps in writing the mechanism of halogenation. So step 1 is initiation, step 2 propagation, and step 3 termination. So to initiate the halogenation, we must have light or heat. And then the highly reactive radicals will be created and it will be carried to the next reaction, which is propagation. So for initiation, step 1, we will have one equation where homolytic cleavage happens. So by using the previous example, the first step will be the chlorine will undergo homolytic cleavage, which the single bond will break symmetrically. So means that one atom from chlorine will be given to each of the chlorine atoms. So you will have two chlorine free radicals. So remember, you must write heat or UV in the equation. And here the arrow used is a half-headed arrow showing that one electron is given to each chlorine atom. So next we are having the next step will be propagation. So in the step 2 propagation, there will be two equations involved. So propagation is one radical will generate another radical. So from the previous step, we have formed a chlorine free radical. So it will react with our alkane. So what happens is one electron from the chlorine will react with another electron from the single bond, okay, from the CH bond. So one electron from the CH bond will combine with one electron from the chlorine free radicals to form HCl, and another electron from the single bond will be given to carbon. So we will have the carbon free radicals. So the carbon free radicals can also react with the chlorine gas. So one electron from the carbon can also combine with one electron from the single bond. So another electron will be given back to the chlorine. So we can form 1-chloro-2,2-dimethyl propane and chlorine free radicals. So the 1-chloro-2,2-dimethyl propane, this is the product, which is our alkyl halides. So propagation, we will have two equations which free radicals are formed. So the free radicals from the propagation will be carried forward to the termination, where when the free radicals meet each other, termination will happen. So termination is a step 3. So for step 3 termination, there are 3 equations involved. Termination is where 2 radicals combine, so there's no new free radical generated, so the chain reaction will slow or stop. So step 3 termination, it will happen because of the free radical. So just now we have the carbon free radicals and the chlorine free radicals. So what happens is the carbon free radicals can combine with another carbon free radicals. So one atom from each of the carbon will combine to form a single bond. Or the carbon free radicals can also combine with the chlorine free radicals. So they will form 1-chloro-2,2-dimethyl propane. Or the chlorine free radicals can also combine with another chlorine free radicals to form the chlorine. Okay, to form the chlorine gas. So based on the termination, there are 3 equations involved, and we can also get the 1-chloro-2,2-dimethyl propane, which is our alkyl halide from the termination. So our product we can form through propagation and termination. So here's another example of the mechanism of halogenation. So the structure is a ring, so it's our cyclohexane. So for cyclohexane, all the hydrogen is also equivalent. So each carbon will have 2 hydrogen, and all the hydrogen. Okay, so here is a secondary carbon, so all our hydrogen is secondary hydrogen. So in the presence of light and chlorine gas, the Cl will replace or will substitute one of the hydrogen atom to become chlorocyclohexane, and we have the HCl formed as a byproduct. So in order to write the correct mechanism, you must know how to write the correct product from the reaction. So termination, there will be 3 equations involved, where the chlorine free radical can react with another chlorine free radical to form the chlorine molecule, or the carbon free radical can combine with the chlorine free radical to form our product, which is chlorocyclohexane, and also the carbon free radical can combine with another carbon free radical to form the dicyclohexane.